Chapter 13, question 10 asks you to draw the Fischer projection for each of the following dash wedge structures. And really quickly, just remember that the dashes mean that the bond is pointing away from you, and the wedges, and so an example of the dash would be like that, the wedges mean that it's going toward you. And an example would be right there. So those dashes and wedges are useful because they give you the three-dimensional arrangement of bonds, of groups. And that's important when you're trying to determine whether a carbon is left or right-handed, which is often important in knowing whether a drug works or a hormone works or not. So, in other words, those dashes and wedges are useful for drawing chirality, chiral carbons, handedness. Now, some molecules have a lot of handedness. Sugars are an example. And if you work with a lot of molecules that have a lot of chiral centers, that have a lot of handedness, then it's nice to have a quick way to draw them. A quick way to draw molecules that have a lot of chiral centers is a Fischer projection. And in a Fischer projection, the vertical bonds are all assumed to be going away, and the horizontal bonds are all assumed to be going toward you. So in these, you'd redraw the structure. This structure here in A, draw the carbon with the functional group. Here, this is an aldehyde. Then just draw a vertical bond until you get to the end. You draw in that tail there, so CH2OH. Those vertical bonds are all going away. They're the dashes. The horizontal, then any carbon in the middle, you draw a horizontal bond for that. On the right we have bromine, on the left we have OH, and those horizontal bonds, these bonds right here, are assumed to be coming toward you. And so we drew a really quick structure, but because of the implication of those horizontal and vertical bonds in the Fischer projection, it gives us a lot of information and tells us what handedness that carbon is, whether it's right or left-handed. You could figure it out using the three-dimensional structures. Okay, so let's try to do the same thing here for B. So you draw that group at the top. Here, this is an aldehyde, so carbon double bonded to oxygen, single bonded to an H. The vertical bonds, until you get to the very bottom, you can draw that bottom group in. Those vertical bonds are all going away from you. For any carbon in the middle, draw a horizontal bond. We can see here on the right of these, and just to point out what I'm looking at, these bonds here are these. We can see that on the right of that bond, we have a hydrogen. On the left, we have an OH. And so that would be the Fischer projection for that molecule. Last but not least, this third one, draw the top carbon, and here this is an aldehyde. Carbon double bonded to oxygen, single bonded to hydrogen. Draw a vertical bond that's assumed to be going away from you until you get to that bottom group, CH2OH. Leave that the same. So here this vertical bond is understood to be going away from you. For any carbon in the middle, draw a horizontal bond. So horizontal, and that's going to be assumed to be coming toward you. You can see to the right of that horizontal bond, you have an OH, and to the left, you have an H. And so that would be the Fischer projection for that molecule.